Welcome to Mimi's Math Channel. Today I will explain how to solve rational equations using various methods. The first method is cross multiplying. I am going to take 6 and multiply times the entire expression 2y minus 1, and then I'm going to set that equal to the product of 4 times 4y. Now what you want to do is distribute on the left hand side. At this point you want to go ahead and combine your y's and put the constant on the side by itself. Now you want to simplify so that y is on the side by itself. So y is going to be negative 3/2. So you want to go and check your excluded values, which in this case is y cannot equal 0. I'm looking only at my denominator where there's a variable. I want to set that equal to 0. What does it tell me that y will equal? 0. So therefore, I know that I cannot have a 0 in my denominator. So that is my excluded value. Since this is not 0, I can go ahead and say that negative 3/2 is the answer. Example 2, I'm combining like denominators. I don't know that these are the specific names for these methods. This is just what I call them in class. Combining like denominators simply means that I see that both of these denominators are the same. However, they are on opposite sides of the equation. So what I would do is take one of them and move it to the other side. I'm choosing to take the 1 because 4 is bigger than 1, so I just want a positive number, but there's no rhyme or reason to which one should be moved. I can just go ahead and make one big fraction bar with that 3x. 4 is already over there. The 1, I have to change the sign because it's going across the equal sign, so it's now negative 1. And then I can combine like terms. And what I want to do is use that first strategy that I had, which is cross multiply. 3x is going to equal 24, which is 8 times 3. And now once I solve for x, I see that I have 8. Before I can say, yay, 8 is my answer, I need to go and check for excluded values. So since both of my denominators that have the variable x are the same, I only have to set this equal to 0. And once I do that, x is actually 0. So for example 3, the least common denominator method. Before I do anything else, I want to factor the denominators. So I see that this one is already in factored form. This is already in factored form. The last fraction is a difference of 2 squares, which is the quantity of x minus 1 times the quantity of x plus 1. If I'm paying attention, 9 times out of 10, the answer for the factored form is already there. So what you notice is for each side, I went ahead and wrote the LCD. This is all one fraction over 1, and the rule says that we can cross simplify. So on the outside I have a quantity of x minus 1, and I also have a quantity of x minus 1 for this first fraction. Now what's left over, I'm going to have to distribute to the numerator that is already there. And now I have this minus sign here. So what I did was take the negative that was in between the two fractions, and then I went ahead and I made sure to change the sign of each term. On the outside, I see my LCD has the quantity of x plus 1, and so does the denominator of the second fraction. So what's left over, I'm just going to go ahead and write on the next line. The second fraction I'm adding. Now I have an equal sign. On this side, I see that my LCD matches the entire denominator. All I have to do is just bring down the 10. If I am doing this correctly, I will no longer have fractions. I just need to distribute each set of binomials. So once I expand those binomials, what I'm going to do now is just combine like terms. So what I notice is my x squareds canceled out as well as my constants canceled out. And so now solving for x, I'm going to divide both sides by 10, and therefore x is going to equal 1. Before I can say 1 is my answer, I would have to go back to my original denominator and check for excluded values. Here, x cannot equal positive 1 and negative 1. So since this actually did come out as 1, I'm going to scratch through that, and I'm going to write that my answer is no solution. So for example 4, I call this the what's missing method. What you're looking for is what's missing in the denominators. So that means that we're going to try to find our LCD. What I usually do is color code. I want something in common with that 5, so I'm going to break that 10 down, and then I notice I have x squareds. All of these are multiplying times each other. So I like to color code so I can clearly see what's going on. On the left-hand side, I'm missing not only a 2, but I'm also missing a another x. I look at that and I multiply everything together. Now that I know that I'm missing the 2x in the first fraction's denominator, I'm going to go ahead and include that. And then I am also going to include it in the numerator. So I noticed that I have an expression there, so I'm going to have to distribute this 2x to both terms. If I look at the 1, well, what's missing? All of it is missing, the entire 10x squared. So I have to include that. And there's a negative sign here, which goes with this 1. If it were an expression, I would have to distribute that negative to each term. On the other side, I see I'm not missing anything because I have my least common denominator already there. So when I go to the next line, I'm just going to bring that 4x down. I am going to go ahead and simplify it, and this is what the next line would look like. Now, what you should notice is if you are doing this correctly, you no longer have fractions. And the reason you no longer have fractions is because of the method we used a few minutes ago. This time I'm just going to show one big parentheses. We put our least common denominator on the outside, and once we did that, we could actually just go through and cross simplify, and you will notice all of the denominators will go away. I will no longer have fractions. So now I'm going to combine like terms and simplify. So once you get to this point, you have x squared and an x term, but you don't have a constant. I am going to go ahead and factor out a GCF, and that's going to be negative 2x. So negative 2x times what will get me back to negative 8x squared minus 10x, and that's going to be 4x. This sign changes because there's a negative on the outside, so plus 5. And this is all set equal to 0 because we are solving. So I have an x here, which means negative 2x is going to equal 0. So what will x equal in this case? Well, it's going to be 0 divided by negative 2, which is 0. Over here, I have 4x plus 5 is equal to 0. And then I would just solve for this by subtracting 5 on both sides and dividing by 4. So x is going to equal negative 5 over 4. Now, I need to check my excluded values. My original, which is in blue, had 5x is a denominator, so x cannot be 0. And then the same thing with the 10x squared. X still cannot be 0, which tells me that my answer that shows 0 is not a valid answer. However, I can keep this one. Thank you for watching. Please remember to like and subscribe. Have an amazing day.